Alphabet is the only Mag 7 stock positive on the week.
Be rough out there for a bit, as Google's recent progress could create some temporary economic headwinds for them. But the bubble bursting or even maybe deflating could be existential for Altman and OpenAI. It's across AI mode, so that's potentially billions of users who aren't even necessarily looking for a chatbot. They're getting the power.
Tech giant just made a rare change, putting AI much more front and center, pushing its AI mode tool in front of billions of users.
Google just dropped something that could change everything about AI, and almost nobody's talking about it yet. While everyone's focused on the latest chatbot updates, Google quietly published research that might have solved AI's biggest weakness, the one that's been holding back every major model from ChatGPT to Claude to Gemini. And here's the kicker. They did it by copying how your brain actually works. See, right now, even the most advanced AI systems have the memory of a goldfish. Sure, they can read an entire book in seconds, but ask them about chapter 1 after they've reached the end. Good luck, reset the conversation. They forget you exist. It's like having a genius assistant with severe amnesia. But Google's new Titans Miris system changes all that by giving AI something revolutionary, actual long-term memory that updates while the model is running. So today, we're breaking down exactly how this memory breakthrough works, why it matters more than you might think, and whether Google just secretly leapfrogged everyone else in the AI race.
First, let's understand why AI has such terrible memory in the first place. The culprit is actually the same technology that made modern AI possible, transformers. These are the backbone of virtually every large language model today. They use something called attention mechanisms, which basically means the AI constantly scans through everything it's been told to figure out what's important right now. This worked brilliantly when we were dealing with shorter texts. But here's where it gets messy. The computational cost of attention doesn't just grow with longer inputs. It explodes exponentially. Feed it a full novel, a massive codebase, or genomic sequences, and the system starts buckling under its own weight. To cope, it starts dropping earlier information to make room for new stuff. Researchers call this catastrophic forgetting, or the goldfish problem. Now, smart people have tried fixing this. New architectures like efficient RNNs and state space models such as Mamba 2 can handle longer sequences way faster, but they compress everything into tiny fixed memory slots, losing crucial details in the process. It's like trying to remember a movie by writing a single sentence about it. You'll get the gist, but miss everything that made it special. This is where Google's approach gets interesting. They didn't just make memory bigger or faster, they fundamentally rethought how AI should remember things. Titans is the actual architecture, the tool that does the remembering. Miris is the blueprint, the theory explaining how to build these kinds of memory systems. Together, they introduce something genuinely new, test-time memorization. Think about that for a second. Current AI models can only learn during training. Once they're deployed, their knowledge is frozen. But Titans can learn and store new information while it's actively running, deciding what's worth keeping permanently. It's the difference between a textbook that never changes and a notebook where you can add new pages whenever you discover something important. The way Titans achieves this is by mimicking human memory architecture. Just like our brains, it splits memory into two distinct systems. Short-term memory handles immediate context using traditional attention mechanisms. But then there's long-term memory, and this is where things get wild. Instead of just being a bigger storage space, Titans uses an entire neural network dedicated solely to understanding and preserving the big picture. But here's the really clever part. How does it decide what to remember? Google borrowed another trick from human psychology called the surprise metric. Think about your own memories. You probably don't remember what you had for lunch 3 Tuesdays ago, but you definitely remember that time something completely unexpected happened at work. Our brains are wired to forget routine stuff and remember surprises. Titans does the exact same thing. When processing information, it constantly predicts what should come next based on patterns. If the prediction matches reality, low surprise, don't bother storing it. But when something breaks the pattern, high surprise, lock that memory in permanently.
Example of this is Project Suncatcher 2 weeks ago, where we announced we're going to build data centers in space.
He challenged us to think about applications in healthcare, education, agriculture.
It's a matter of time. And so how do you make progress on that? You work back and have 27 milestones.
Google's own example is perfect. Imagine an AI reading a serious financial report when suddenly there's a picture of a banana peel. That unexpected element gets maximum surprise score and permanent storage. But Google added two more psychological tricks. First is momentum. When something surprising happens, Titans also memorizes the next few tokens, even if they're not individually surprising. Just like how you'd remember not just a shocking event, but also what happened immediately before and after. Second is adaptive forgetting. Old memories that stop being relevant gradually fade away, preventing the system from getting cluttered with useless information. Now, Titans is just one part of this breakthrough. The real genius comes from pairing it with Miris, a framework that completely reframes how we think about AI memory. Miris makes a bold claim: every AI architecture, whether it's a transformer, RNN, or something totally new, is fundamentally just a different approach to memory. They're all trying to solve the same core problem, combining new information with past knowledge without forgetting important stuff. Miris breaks this down into 4 key design choices that any memory system needs to make. First, memory architecture. What form does the memory take? Is it a simple vector, a matrix, or a complex neural network like Titans uses? Second, attention bias. What gets priority? What does the model focus on most? Third, retention gates. How does forgetting work? What mechanisms prevent important memories from drifting or degrading? Fourth, memory algorithms. How do you update memories while the model is actively running? This framework is powerful because it stops us from thinking about different AI architectures as completely separate things. Instead of transformers versus RNNs versus state space models, Miris shows they're all just different points in the same design space, different solutions to the universal challenge of memory.
It's also true when we go through these investment cycles, there are moments we overshoot.
Over time, at Google, we are always proud of taking moonshots. You mentioned Waymo earlier. That's been over a decade in the making.
Actively add what all the companies are doing. We have well over $1 trillion of investment.
Our first step in 27 will send tiny racks of machines.
We can look back at the internet right now. There was clearly a lot of excess investment.
So does any of this actually work, or is it just clever theory? The early results are honestly shocking. In standard language modeling and reasoning tests, Titans-based models consistently beat the best linear RNNs and transformer variants of similar size. Lower perplexity scores, higher accuracy, better performance across the board. But the real test comes with memory depth. Models with deeper memory systems consistently achieve better results. And more importantly, they maintain that performance as sequences get longer. While other models start failing as input length increases, Titans just keeps going. The benchmark that really shows this off is called baby long. It hides important facts across massive documents, sometimes millions of tokens long, then asks the model to reason over all of it. Every other model, including GPT-4, Claude 2.5, and Mamba, sees performance crater as documents get longer. But Titans? It maintains strong performance even at extreme lengths. Here's what makes this even more impressive. Titans achieves these results while being way smaller than the models it's beating. It's not just better memory, it's more efficient memory. Google didn't just make context windows bigger or tweak attention mechanisms. They created a fundamentally new class of AI models that can actually remember and learn while they're running. Think about what this means for AI agents and assistants. Right now, they're limited by their goldfish memory. They can't follow complex projects over weeks or months, can't build genuine long-term understanding of your needs, can't accumulate knowledge from ongoing interactions. But with true long-term memory, continual learning, massive context handling, and real-time adaptation all working together, we're talking about AI that could actually work alongside humans on extended timescales. This could be the missing piece that transforms AI from a clever tool into something more like a genuine colleague. Imagine an AI that remembers every conversation, learns from every interaction, and builds understanding over time instead of starting fresh every session. That's the promise of Titans plus Miris. Now, has Google completely solved AI's memory problem? Probably not yet. There are still questions about how this scales to truly massive deployments, how it handles conflicting information over time, and whether the surprise metric might miss important but unsurprising patterns. But this feels like a fundamental breakthrough, not just an incremental improvement. The combination of human-inspired memory architecture, smart forgetting mechanisms, and the theoretical framework to understand it all, this is the kind of research that could define the next generation of AI systems. While everyone else is making chatbots slightly smarter, Google might have just figured out how to give them actual memories.
What's your take on this? Is long-term memory the breakthrough AI has been waiting for? Or are there other limitations we need to solve first? Drop your thoughts in the comments below. And if you found this breakdown valuable, make sure to hit that like button and subscribe for more deep dives into the latest AI breakthroughs. That's it for today, folks. See you in the next video.